Hi everyone. Today we want to look at functions, and we want to determine if those functions are going to be linear or non-linear. Okay, so if we do a quick review, and let's say we look at a table, and we want to determine if something is a function. Okay, we've said from previous lessons to determine if this is a function or not out of a table, all we need to really do is check our x values and make sure the x does not repeat. So if we look in this table, I say I have a 1, 2, and a 3, so x does not repeat, so yes, this would be a function. Okay, but today we're going to take that a little bit farther, and we want to know, is this a linear function? So linear means if I graph these, would I get some type of straight line? Would it be straight going this way, straight going this way? Or does our line get like a curve to it or something? Okay, curve like this. This would be non-linear. So we want to determine, is it linear or not? Alright, so here's how we do it with a table. Once we see the table of values given to us, and let's say we have this one. Okay, so we have the table of values of 1, 2, 3, 5, and 5, 8. We want to know, is this going to be linear? Yes, it's a function because the x doesn't repeat, but is it linear? To be linear, we must see a constant change, a constant pattern happening on both sides. So now we have to look at what's happening in both places over here. So if I'm going from 2 to 5, I'm adding 3. Does that continue through here? From 5 to 8, I'm also adding 3. So it's constant in both spots. But it needs to be constant on this side as well. So from here, I'm going from 1 to 3, I'm adding 2. Well, from 3 to 5, I am also adding 2. So it is constant on this side as well. As long as it's constant on this side and constant on this side, the same thing's occurring, then yes, this is what we call a linear function. Okay? So let's look at some more examples out of tables. We want to know, is this a linear function? If I look on this side, do we have a constant change always happening? I went from 7 to 4, I went down 3. From 4 to 1, I went down 3. So yep, it's constant there. On this side, I'm adding 2, and from 3 to 5, I'm adding 2. So as long as it's constant once again everywhere, then yes, this is a function. A linear function, excuse me, not as linear. Okay, would this be a linear function here? Well, right off the bat, we see that 1 repeats, so I can stop and just say no. Okay, it might be linear, but it's not a function, so therefore it's not a linear function. Okay, if I flip that, and I look at this case, well now if I look at my x's don't repeat. Okay, so we're safe there. Now we want to see, is it linear? Do we always have a constant change? Well, from 1 to 1, I went up or down 0. And from 1 to 1, I went up or down 0. So that's fine. That's still a constant. Nothing happened there. Okay, it stayed the same. But does it happen over here? We went down 4. We went down 4. So it's the same there. So in this case, yes, this is what we would call, once again, a linear function. Now let's say we had 1, 3, 7, 5, 7, 9. Okay, on here I'm going 5 to 7, so I'm adding 2, and 7 to 9, I'm adding 2. So yes, we would be safe. Over here, I went from 1 to 3, I'm adding 2. But now from 3 to 7, I'm adding 4. So you see that we are not the same anymore. So this would not be a linear function. Okay, so it's got to be a constant in every spot. All right, let's give it one more example of not linear functions out of tables. So if we went 2, 0, -2, and over here we went 5, 8, and let's go 9. So on this side we went down 2, and then from 0 to 2 we went down 2 again. So we're safe there, but if I look over here, from 5 to 8 we added 3, and from 8 to 9 we added 1. So we're not constant there, so that is not linear. Okay, so that's how you tell in a table of values if it's linear or non-linear. Okay, and you'll do some examples of those today. That's kind of the hardest one, I think. The other ones, you might be given some graph pictures, and they'll give you a graph picture and they'll say something like that. And they'll ask you, is that a linear function? Well, we know to be a function, it has to pass the vertical line test. They can only hit the graph one time. So if I draw a vertical line anywhere, yeah, I hit the graph only once. And now you ask the question, is it linear? Is it a straight line? Well, yep, it is. So yes, that is a linear function. Let's say you're given the graph that looks like this. Okay. Well, it is a function, right? It does pass the vertical line test. No matter where I draw a vertical line, I hit it only one time. But definitely not a straight line, is it? So therefore, it is not a linear function. Okay, so it has to be both parts today. And if I gave you one like that, well, yep, that would definitely be, yes, a linear function. Okay, and if I gave you one like that, well, it is linear, but it fails the vertical line test, right? Hits it more than once, so not a linear function. Okay, so looking at graph pictures, you're just going to see, make sure it's a function, does it pass the vertical line test, and then you just have to tell me yes or no, is it linear or not. So yes, linear function or not linear function. Okay, and the other way is you might give an equation to you. If we were given the equation, let's say y equals 2x plus 4, and I want to know, is that a linear function, yes or no? Okay, well, hopefully some of you are thinking, well, wait, I could graph this, couldn't I? And it has a starting point, a beginning point at 4. So if we went up to positive 4, and then my slope tells me to go up 2 and right 1. And if I kept that going up to another right 1 and kept going up to another right 1, I would get this. Well, yes, it passes the vertical line test, and it is straight, so yes, it's a linear function. Okay, but I don't need to graph it. That takes too much time. There's got to be a shortcut. There should be an easier way that we can just look at it. So here you go. If you look at the equation, and you see your x, and x is only to a power of 1, then yes, you know it's going to be a linear function. So if I wrote y equals 1/3 x minus 2, well, I don't care that's a fraction, that's our slope. We want that, up 1 right 3, right? We want it to be a fraction. That doesn't mean anything. Look at your x. What power is it to? It's only a power of 1. So yes, it's a function. Okay? Hint, hint. Everything that Mrs. Brimhall and myself in our classes that we've been graphing, they've always been linear, right? We've always had a power of 1 there. All right? But now you might see an equation that looks something like this. Okay? We're not asking you to graph it. We just want to know, is it linear? And well, once you see that x has a power of 2 on it, you simply just say, no, it's not a linear function. That's all you got to do. Okay? So if the x is raised to some power, as soon as you see that, that's a dead giveaway. It's a no. So you can just say no. Okay? And then there's one other little catch. If the x is in the denominator, okay, so we put the x down here. So you notice on this one, the x was up on the side, right? It's kind of like up with the 1, right? Or this one, the x is really on the side, but it's to a 3. But the x on the side, that's different. But once we put the x down here, even if it's a power of 1, it's still no. Okay? So it's okay if you say this, and you put the x in the top, in the numerator, then it's okay. That is still yes. Alright? But that's no. So you tell me if I do this to you. Would that be yes or no? Well, it's in the top, so is it yes? Oh, no, because it's got a power of 2, so hopefully I didn't trick you. Tried to trick you on that one. That's a no. Okay? Can't be in the top. I mean, it can, excuse me, can be in the top, but can't have a power on it, right? And what about this one? Power of 1. Ah, but he's in the bottom, right? So that's a no. Okay? So, summary of this, you just want to make sure it's an X, it's in the top, and then it's a yes. Power of 1, and then top, yes. But once you see the X has a power on it, it's no, or if X is in the denominator, it's no. Okay? So you're going to get a worksheet from Brimhall and myself. You simply just have to do that. You have to look at tables, see if they have constant change on both sides, and tell us yes or no if it's linear or not. And you'll be given some pictures of graphs, and then make sure it passes the vertical line test, and make sure it's straight, and that makes it linear. And then you'll be given some equations, and you just have to look at the equations and determine if theirs are linear or non-linear. Okay? If you have any questions, reach out to either one of us by email. We'll be happy to help you.